Section 2.3 and 2.7, Quadratic Functions and Their Zeros, Part 5. In the last video, we talked about example 5 and the discriminant. And I told you that in this particular problem, we have two real zeros. But one thing I forgot to mention is, what is the discriminant in this problem? Well, the discriminant is what's inside the radical. In this particular problem, then, our discriminant is positive 25. Because 25 is positive, that means we have a real solution for that part. We don't have imaginary because it's not negative. There's no negatives inside the radical. And then, of course, that plus and minus gives us two real solutions. And I just wanted to point that out, that the discriminant is 25, positive 25. Let's move on and let's solve this same quadratic equation, but this time we're going to complete the square. Now, this is the one that most students have trouble with. So if you need to press pause, please do so at any time. And I'm going to write our quadratic equation first. Okay, we still are solving for the zeros, so we have to set it equal to 0. The first thing you want to make sure is that the leading coefficient is 1. Our leading coefficient is the number in front of the variable that is squared. So in this case, our leading coefficient is 2. And we need that leading coefficient to be 1. So in order to get rid of it, we're going to divide every single term on both sides of the equation by 2. And that gives us x squared minus 7 half x plus 3 halves equals 0. Next, we want to move the last term to the right side of the equation, our last term being 3 halves. In step 3, we're going to take the middle term, this is a negative 7 halves, and we're going to divide it by 2 and square it, and we're going to add this new number to both sides of our equation because we have an equal sign. Whatever we do to one side, we must do to the other one to keep the equality of the equation. Let's go ahead and do that now. Now, one thing I do want to point out is that dividing by 2 is the same as multiplying by a half. Because I have a fraction in this case, I'm actually going to multiply by a half instead of dividing by 2. And then remember, whatever you do to one side of the equation, we also have to do to the other side of the equation. I also want you to notice that I only took positive 7 halves. I didn't take the negative 7 halves because we're going to square it anyways. So every time you square a negative number, it always turns into a positive one. So we're just going to leave that one like that. And we have x squared minus 7 halves x plus 7/4 squared is equal to negative 3 halves plus 7/4 squared. Now on the left side, I'm actually going to leave that part of the equation like that. I'm not going to simplify the 7/4 squared, and you'll see why in a second. I'm just going to simplify the right hand side of this equation. Okay. So first step, I'll add the fraction in a second, but for step 4, we want to factor the perfect square. So this is why this is called completing the square, because we end up with a perfect square. So this one here, we're going to factor, and you'll see why I didn't simplify the 7/4 square, this one here. Okay, I just highlighted the term that I'm talking about. So I didn't simplify that highlighted term because it's easier to factor the perfect square when I have it like that. Okay, so what two numbers multiply to get me 7/4 squared. That's easy. It's just 7/4 because 7/4 times 7/4 is squared. Now, this is a perfect square. It always is going to be a perfect square. That means that these signs have to be exactly the same. They're either both positive or they're either both negative. Well, what are they? Are they positive or negative? They're going to be negative, and the reason they're going to be negative because remember that these guys, the negative 7/4 and the negative 7/4, do have to add up to give me the middle term, negative 7/2. And negative 7/4 plus negative 7/4 is negative 14/4, which if we simplify, that simplifies to negative 7/2. And that's how I know that I have to use the negatives on both terms. And again, these are perfect squares, so they're either both negative or they're either both positive. Okay. And I'm going to go ahead and simplify actually that fraction on the right hand side since I'm already here. So let me do it on the side over here. We have negative 3/2 plus 49/16. I need a common denominator. So my common denominator is 16. So negative 3/2, I would have to multiply by 8/8. Okay, so my new fraction is negative 24/16 plus 49/16. And then I'm just going to go ahead and simplify that. And we get 25/16. Okay, so that is just so you can see how I simplify the right-hand side of the equation. So it gives me 25/16. And then this one we're just going to rewrite as x minus 7/4 squared equals to 25/16. Okay, step 5, take the square root of both sides to get rid of the squared power. This is called the square root method. And this is why we want a perfect square, because we always want to then follow this by the square root method. So I'm going to take the square root of both sides. Now, remember that every time you take the square root of something, we get plus or minus. Please don't forget that, or you're going to be short one answer. Okay, so we simplify now a little bit. Square root of 25 is 5. Square root of 16 is 4. So we have two answers, as you can see. I'm just going to add 7/4 to both sides. Okay, so we have two answers. We're not done. You do want to simplify. Always want to leave it in the most simplified form. So we have 7/4 plus 5/4. And my other answer is 7/4 minus 5/4. Okay, so let's go ahead and do the first one. 7 plus 5 is 12. 12/4, that gives us 3. And then in the second part, we get 7 minus 5, which is 2. 2/4. Simplify that, and we get 1/2. So my zeros are 3 and 1/2. And that is my answer. And I'm just going to go up here to show you. Ooh, we got the same thing here, and we got the same thing here. So my answers are all the same. These are just 3 different methods of solving a quadratic equation.